Hi, I'm Lauren. Today I'll be walking through how Visual Studio can simplify your cross-platform development. While this talk will be helpful for first-time cross-platform developers, I'll be focusing on how to transition existing complex workflows to Visual Studio's integrated remote development. Most of the features we'll be talking about require you to install the Linux and embedded development with C++ workload. You can install this workload from the Visual Studio installer. I'm going to open up my Visual Studio installer here and select Modify. And you can see that I already have it installed. There's many ways to set up a Linux environment, including Azure VMs, Hyper-V, having a physical machine, or using Windows Subsystem for Linux. We recommend using Windows Subsystem for Linux, or WSL for short. WSL provides a fast and easy way to create a Linux environment right on your Windows machine. Visual Studio has the option to install WSL for you. I'm going to open up Visual Studio and select Project from the top menu bar. From there, I'm going to click Install WSL for me. I'll select Yes on the pop-up menu, and then once the system check's complete, I'll select Run Install. Visual Studio's WSL acquisition experience sets up a default user account for you using your Windows environment username. You can change the password for that account and then log in as that user and make any customizations you need for the environment. After WSL is installed, my Windows machine is going to require me to restart, so I'll go ahead and restart my machine. My machine is done restarting, so I'm going to open up Visual Studio again. To use the more advanced remote features within Visual Studio, I'll need to run an SSH server on my Linux machine. So let's go ahead and do that. I'm going to open up a terminal by selecting View from the top menu and clicking Terminal. From the terminal, I'm going to go ahead and open up WSL as the root user. I'm going to set the password for my user account that Visual Studio created for me, which again is my Windows environment username. I'm going to go ahead and log in as that user. And now that I've logged in as my user account, I'm going to install the OpenSSH server, and I'm going to start that service. I've now completed setting up my Linux environment with an SSH server. So now I need to connect Visual Studio to my Linux environment using SSH. To do that, I'm going to open up the Connection Manager by selecting Tools from the top menu and clicking Options. From there, I'll look in the Cross-Platform options and select Connection Manager. I'll click Add to add a new connection, and I'm going to fill out my information here to connect to my remote machine. Now that I've filled out all of the information I need, I'm going to click Connect, and it'll ask me to accept the authenticity of the host key, so I'll go ahead and select Yes. For those of you who have multiple remote environments, you can continue to add as many environments as needed. Once you finish adding your environments, even without having any project open, you've already unlocked some key features in simplifying your development experience. Visual Studio has an integrated terminal which creates an easy way to open an SSH terminal to any of the connected remote machines. You can open it by selecting View from the top menu and then clicking Terminal. From the terminal window, I'm going to select the drop-down and then choose my SSH connection that I've just set up. You can use this integrated terminal the same way you would if you manually started an SSH terminal or if you were to log on to the actual machine. You can install software, check running processes, change environment variables, all without leaving Visual Studio. The integrated terminal removes the need to manually set up separate terminals to run development commands. But if you're like me and you don't like navigating or editing files through the terminal, you're still probably not sold that Visual Studio can replace your current development workflow. And that's a great point, which is why we have the Remote File Explorer. To open the Remote File Explorer, I'll select View at the top menu and then choose Remote File Explorer. From the Host Target dropdown, I'm going to select my SSH connection. Using Visual Studio's Remote File Explorer, I can upload, download files and folders, search through the file system, copy file paths, and even delete, rename, or edit files and folders. Let's go ahead and test editing a file. I'm going to open up my .bashrc file and add a comment to the top of the document. I'm going to click Save, and my saves will be synced onto the remote machine. To really prove that to you, I'm going to use my integrated terminal to print out the contents of the remote file. So I'll use my Remote File Explorer to copy the path of the .bashrc file, and then I'll use the cat command to print out the output. And you can see here that we have the comment that I just added. I've shown you how you can use Visual Studio to do basic interactions with your remote machines, but let's dive deeper into how it can help your actual development process. Visual Studio supports cross-platform development for C++ projects using MS Build and CMake build systems. If you're unfamiliar with CMake, it's a project system meant for cross-platform development and allows you to use one project to target multiple environments. To create a new cross-platform project, you can click File, select New, and then choose Project. I'm going to search for the CMake project template and then go ahead and create a new project. If you're looking to add cross-platform development to an existing project, or you have a cross-platform project that is not a CMake or MS Build project type, we recommend converting the project into a CMake project using CMake's official guidance. If you have a C++ MS Build project that currently targets Windows, you can use this open source CMake converter and then add remote configurations to the created CMake project. So let's go back to the CMake project I just created. I'm going to go to the top bar and select my remote machine as the target system. You can see that the configuration auto sets to Linux-debug. That's because of my CMake presets.json file that's created for me. I'm going to open up my CMake presets.json file to show you how that's done. If you look where the Linux-debug configuration is, you can see that there's a condition that checks for the host system name. And if the host system name is Linux, then the Linux-debug configuration applies for that system. When you create a new CMake project from Visual Studio, the Linux configurations will already be added for you. But if you're looking to add Linux support for an existing CMake project, you'll want to follow a similar pattern as this. As you make changes to your CMake list.txt files, especially if you're converting a project to CMake, you can use Visual Studio's CMake debugger to investigate why the cache generation is failing. So let's go ahead and try out the CMake debugger. I'm going to open up my CMake list.txt file and set a breakpoint. I'll then go to the top bar and select Project, and then choose Configure Cache with CMake debugger. From here, you'll see my breakpoint is hit, and we can step through just as if we were debugging a typical project. Once you have a remote project set up, you can build, debug, and run the project targeting any of the remote machines you added to the connection manager. No longer do you need to develop on individual machines or manually transfer files over. For my CMake project, for instance, I can go ahead and build it targeting my remote machine. I can also debug my project. So I'll set a breakpoint, and I'll also change my startup project to be the name of my project. I'll now start debugging, and you can see that we hit the breakpoint and we can step through just as if we were to debug a local project. What if we want to debug a process that's already running on the remote machine? Or what if we had trouble converting our existing project into a project type supported by Visual Studio? Visual Studio supports attaching to remote processes to address situations like this. As a demo, let's change our main function to contain a never-ending loop. I'll save the file and build it from the UI of Visual Studio. But if this were the case of it being a project system that can't be opened in Visual Studio, then you could edit the file from the Remote File Explorer and build from the integrated terminal. I'm then going to run the project by clicking Debug Start Without Debugging, but again, I could have started this from the integrated terminal. When attaching the VS Debugger to a remote process, it will use the debug symbols on the remote machine, so we don't need to have any of the build output locally. To set breakpoints and step through the code, you will need a local copy of the source file to further investigate though. So let's pretend that I don't already have this project set up locally, which would be the case for those of you who weren't able to convert your remote projects yet. I can go to the Remote File Explorer and download a copy of the .cpp file that I want to set a breakpoint in. So I'm going to use my Remote File Explorer and download that CMake project1.cpp file. I'm now going to open up the folder containing the .cpp file that I just downloaded to really show you that you don't need to have the whole project on your local machine to debug a remote process. I'm going to select Debug from the top menu and then choose Attach to Process, and I'll change the connection type to be SSH and choose my desired connection. I'll then select the CMake process that I started, and I'm also going to select the code type to be GDB. For those of you connected to a Mac remote machine, you'll want to select LLDB. I set a breakpoint inside of my infinite loop, and once I select attach, you'll see that we'll hit that breakpoint, and we'd be able to debug and step through this project just as if we were to build it locally. By using the remote development features within Visual Studio, I've shown how you can have a complete cross-platform workflow without ever leaving your Visual Studio instance. I ran commands using the integrated terminal, edited and viewed the file system using the Remote File Explorer, built and ran projects targeting my remote machine, and even attached the VS Debugger to remote processes. Developing cross-platform projects is enough stress as it is. Let us handle the tedious setup so you can focus on creating a great project.